Hello friends, welcome to Head or Tail Education. Today our topic is related to data structure, or in the data structure our topic is self-referential structure. Now first we understand to about the normal variable and array, or we can say secondary variable or secondary data type means like. So first we understand what is the structure. So structure is a collection of primary, secondary or user defined data type, also called user defined data type. So first we understand what is the primary data type. So primary data type is like a character, integer, float, double, long, etc. Okay. So if we have the character variable, we can create character variable ch1 and assign h, integer variable assign, create age, value assign 23, floating point variable float, we assign which name is rating, assign 4.5. Now long variable like populations, so we assign the populations. Okay, so this is a primary variable. Now what is the secondary variable or secondary data type? So secondary data type is a collection of primary data type, is called array. Means if we want to store more than one character, okay, so we can create secondary data type variables. Like we have a small example here, character string array, or we use the assign string world, WORLD world. Okay, so if we individual variable created, so we can create like ch1, ch2, character means character ch1, ch2, ch3, ch4, like this. Now this time in array we have only single name str, okay, and assign value world. So automatically array created these all variables in memory location with continuous allocation. So the length of this string is 1 2 3 4 5. Okay, so 5 variables is created. Okay, and last is terminating variable, this is called null. So this is the secondary data type. So we can create like array of integers, array of floats, array of long, or array of any user defined data type structure. Okay, now first create structure or user defined data type. So how can we create the structure? So I already told you, so structure is a collection of primary and secondary data type or user defined data type, like this. So here I have created the struct myDate. Okay, so created one character secondary data type variable month and size is 5. Other I have created primary data type integer dd means date and year. Okay, so this is primary data type, and this is the user defined data type, because my data type is not available in standard data type. Okay, so this is custom data type, so this is called user defined data type. So my data type variable name is here today. Okay, so today like here I'm in month I have assigned July, JUL, date 12 and year 2025. Okay, so this is the data structure. Now other example I have created here user defined data type or custom structure like employee. Okay, so employee name is a here secondary data type which is array, primary data type integer age, primary data type float salary, and custom data type or user defined data type variable struct my date. Okay, which is date of birth. So this is the collection of primary, secondary and user defined data type. So this is the representation of like this. Okay, So name Lucky, age 23, salary like this, and date of birth is the one user defined data type structure. So I added here this, so month, date and year. Okay, so this is the object of employee variable. Okay, employee structure variable. Now next, how to accessing the structure variable. So this is the structure variable employee, character name, age and this is the structure variable employee emp. Okay, this is a struct data type and this is struct. So if we use, we have, this is the normal variable. So if we use age, so emp dot age equals to 23, directly we can assign age, or we can read as employee dot, if we use custom data type variables like dob, so employee dot dob dot year equal to 2001 directly. Okay, but we need to separate by dot. Now if we have the pointer, so struct employee pointer ptr, so equal to address of emp pointer. Okay, so emp pointer I have assigned the address of employee variable. Okay, so if we want to access the age of this structure, so ptr pointer name and arrow sign and variable name age equal to 23. Like if we nested structure variable, so we pointer arrow sign. Okay, but here I am using dob dot year because dob here is not a pointer, this is the variable. So ptr arrow dob dot year equal to 2000. So this is the accessing method of structure variables. Okay, now comes to our main end point. Okay, main point. So first we understand what is the concept of self-referential structure. So again we come our variable. So for example, here I have created 6 variable of character data type. ch1 equal to h, ch2 equal to e, ch3 equal to l, ch4 equal to l, ch5 equal to o, and ch6. I have not assigned ch6. Okay, so each variable is created in memory on different location. Wherever the memory is free, variable is created or allocated the assigned value. If I have not assigned this value, so variable is assigned the garbage value, like in variable ch6, this is the garbage value. Okay, so what is the process? Find free space or unused space, variable is created. Okay, if variable is not initialized, then may be empty or garbage value by default. Now this is in previous slide we have no issue, the variable is created anyway. Okay, but issue is if we have a large string like 100, 500, 1000 characters or above, then we can use array to store string, but each time is not possible because array uses continuous memory allocation. So it totally depends on availability of memory. Otherwise, during execution of program, show error or other program in hang modes due to unavailability of memory. Okay, so for example, so the above paragraph, this paragraph, the total length is 349 characters. Okay, so according to array, if we need 349 character allocation in memory. Okay, if we created array, we need 349 characters, but the condition like below. Maybe some other programs are running in our computers, so all the gray boxes is uses memory. Okay, and the few boxes empties are available. Now according to our array, I have assigned this paragraph to array, but our condition is like the issue not fully allocated for this. Okay, so this is the problem. So this is the possibility to show error our program, or other programs also maybe hang because our program is trying to allocate the memory for array. Okay, now again we check. So to avoid this type of memory issue, okay, we use the self-referential structure. Self-referential structure concept can use to make like queues, binary tree and others. In our tutorial, I explain about simple self-referential structure linked list. Okay, so again we check this example. So example, we have a number like this long number. Okay, 34985634389753421. Okay, and store in a part and store address in pointer. Okay, why I am storing in a part is this number, because this type I have no data type to store this number. Okay, so we have to store this number in as a string and format. Okay, but our programs have fully used this memory and we have no memory for this. Now this time we have available memory but in splitted mode, so we can store the number. So gray box all other programs for uses, empty box for empty memory, and yellow boxes for our program variable memory. Okay, so now according to this memory chart, so it started from 23436. Okay, this is the location number and all is free and 3498 is available. So according to our dynamic memory, 3498 store in this location, 21 store I have on this location, 563 in this location, 43 in this location, 53 in this location, 8 in this location, 4 this location, 7 9. So each number is allocated different location. But now if we run the sequentially, our we can't uh, check our number is okay or not, because in sequentially this number is disturbed wrong. So for this issue, so each number we have the address. What address? Like the initial this memory address is 23436. Okay, so now 36 37 38 39 40 41 42 43, so three number allocate this address. Okay, now four number allocate 444. Okay, to 23. Now 9 number allocate 23 445. 8 number allocate 23 446. Okay, now again 5 number, so 5 number allocate in 23 460, because maybe this time the continuous memory is not available and allocated free available in this location. So fifth number is allocate this location. Okay, sixth number this location 461 and 3 number this location. Okay, now next 23 483, this is the fourth location, so 4 number. Okay, so this place memory available, so we allocated the memory on this location. Okay, so here we added two numbers, means 483 location and 384 location. Again the 8, so 8 find the memory location 491. Okay, and 9 find the memory location 496. Now 7 find the memory location 477, this place, and 5 find the memory location 50523. Okay, this location. Again, so 5, then 3 3 location is this location 506. Okay, so this is 505 506, and fourth assign the location 5012, this location. Now last two numbers we find the location 543, so this location. Okay, and one is assigned 23454, this location. So each variables we allocate it on different location. So to address of complete number, we need to store the address according to storing sequence. Okay, so this is called the self-referential structure we need for this. Okay, so this is our data part 3 4 9 7 5 6 and so data part is like a simple variable, or can any like structure variable or custom structure, user defined, maybe the student structure, employee structure, company structure. This type of data we can store in this side. And the below this is the all have memory address. So memory address size is only the 2 byte for this. It depends on the compiler, so which size is available in data type. But initially the we store the integer like 2 byte. Okay, so this is so, but the data part is maybe the bytes are long, like because I already told you this is maybe the employee structure, so maybe the employee data have the employee name, age, salary, basically company name, address, phone number, pin number, like this. So maybe the 100 400 200 like this. Okay, so if we have this type of data, so that time the we face the memory issue. Okay, so that's why we need the solve to this issue, we need self-referential structure. Okay, now create a self-referential structure. How we can create this? Okay, so we in previous slide we already see our number like this. Okay, and this is the sample memory allocation chart. Okay, so start from 23 436 and 36 30 and so on. Okay, now this is our data 349 856 34389 75342 like this. Okay, so according to this we have to create structure. So here I am creating struct my data. What is my structure name? My data. Now I have only integer number, so I created integer data. Okay, now we need to store the address of structure. Okay, because so this structure, what is this structure name? My data. Okay, now what is inside this name? My data. So both name is same, and here I have created the pointer of my data. Okay, so this is the self-referential structure. If I have created outside variable like this d1 d2 d3 and here pointer list equals to null, so this is outside variable, but all have in these variables the my data pointer next is available. So this is called self-referential structure. So in data part we store the data, and is next part means pointer part we store the data address. Okay, because the pointer is hold to address. So like this. Okay, so here I have assigned the list equals to null, initial with null. Okay, so d1 d2 d3 these three variables, and address is 23443 23444 23445. Okay, this is the address. Now what happen if I assign d1 value? So d1 have 3, okay, data 3, and next pointer I assign null. Okay, now same like d2, this is data 4 and assign null. Same like d3, data 9 and assign null. Okay, so if we check the continuous, so in next pointer we need to next data address. Okay, so but before this we have to check our starting point is null or we have the address. So if our starting point is null here, so we need to first record address. Okay, so this d1 variable address is assigned here. Okay, now so this is already point the list this address now that time. Okay, so list have this address. So on this address we have the data part, value equal to 3. Now next for this have null, so I have assigned the next data address. So our next data is 4. So next data address 23444 is assigned here. So we catch our next data. Okay. So on next data the value is null. So after that I have assigned the next data address D3. So D3 assigned here. Okay. So on this location we have the value 9. So this is the sequence of storing data in self-referential structure. Okay. Now how to add the data by using the code. Okay. So here we have to store 3, 4, 9, only 3 variables, 3 data storing in memory by using the self-referential structure. Okay. So structure is the same, struct my data, integer data, my data pointer next, and I have created 3 variable of my data, d1, d2, d3. One is pointer which name is list, and one other pointer which name is ptr. Okay. Now if we check the code, so if we first call, okay, so this is our function add node. So I have passing the our data, means here I have calling add node and passing first data 3. Okay, so 3 is coming here. Now here I have created one variable for my data type and allocate calling the dynamic memory allocation. So my data pointer equals to my data pointer malloc size of my data. Okay, so this function is dynamic memory allocation for use. Okay, malloc. So in memory any places free or unused, this memory is allocated to my data pointer. Okay, now after that the 3, because I am passing here, so 3 is assigned to my data, and the next pointer, because by default is garbage value is available, so next pointer I have assigned the null value for this. Okay, because first time I have created only 1. Now ptr pointer I have created and assigned the list. So what is the default value of list? List default value is null, means I have no list of any numbers. So first time list is empty, so first time I check list equals to empty, so list assigns md. Okay, means dynamic memory allocation variable md address is assigned to list in first time. Okay, so this is first time I have assigned the list address to md variable here. Okay, now again I have called second call for this. So second call add node 4. Okay, so this time I have to add fourth value variable. Okay, so come is here fourth value. Now again I am function calling dynamic memory allocation and assign new assignment to my data variable. Okay, so is check free or unused memory allocated to memory allocation pointer md. Now assign the data pointer to data value, so 4 is assigned here, and this is assigned next null for this because this variable created newly. Okay, and garbage value is assigned here, so I have by default using this null. Now first ptr equal to list. Okay, so we have already one variable for this in list. Okay, so this time list equals to null, list is not null, this time list is not null. Okay, because one variable is already I have created and one address already available in list. Okay, so we already assigned the list address for this pointer. Now we come see this side else part. Now check our pointer. Okay, so ptr have the same address, this is the list address. Okay, so ptr of next means the list of next variable is null or not. So this is null because in previous I have assigned the null on this list. So ptr next is not equals to null, not equals to null, no null. So this loop is break this time. Okay, and ptr next to assign md variable. Okay, my data variable address. So two address I have assigned here, 3 and 4. So this next I have assigned this address. Now again I have calling 8 node. Okay, 3 9 passing the variable 9. So data, so here again call this memory allocation, dynamic memory allocation, wherever free or unused memory is allocated and assigned to address of this pointer. Now data md arrow data equal to data means 9 assigned to here, and next I have assigned here null. Okay, because this time third call and last I have assigned the null for to stop. Okay, now again ptr assigns equals to list means first address again I have assigned to ptr pointer. So this time ptr is not null, so we come here. So we have already in list two variables. Okay, so first we check ptr of next is not equals to null, ptr of next not equals to null, correct, not equals to null. So we assign ptr equal to ptr next means this address we assign. So again check ptr of next is not equals to null, so this of next is null. Okay, so null, so I have assigned the ptr of next equal to md. So this is the my data variable. Now this time all three variables are added by using the dynamic memory allocation with the self-referential structure. So if we have seen this, so like the structure, like so list have initial address of this variable. Okay, now on this variable the next pointer, this have address of this variable. Now next to this pointer, this have address of this variable, and the last I have assigned the null. So according to our this program I have only created for three list variables, means first variable store this value, second this, and third this. Okay, so list length is our three variables only. Now this is the full program of linked list. Here I have created only two functions to add node or view list. View node means, okay, view list full. So include file name, hash include using namespace std because I am creating in program in C++. So here I am using namespace std. Okay, this is the class which name is my list class. Okay, inside this class I have created struct variable, struct data type my data, int data, and struct my data next pointer. Now rename the structure my data to my data. Okay, here I have created my data one pointer list or one pointer ptr. These all are private variable. Now next again I am using the public keyword for constructor. So my list constructor, and by default I have assigned list equals to null and ptr equal to list, means both ptr and list both pointer points to the null on the first time. Okay, now this is our add function. So here this is the dynamic memory allocation. So created one pointer of my data and assign the malloc by using the dynamic memory allocation, and data assigned to the variable, and next pointer assigned I have null here. Now pointer initialized with the list ptr. Okay, this is the start position. If by default list null means list is empty, so list equals to assign empty. Okay, this is the first variable only run first time. If list have already other variable address, then we need to find what is the last position of list. So this loop is running here while last position. So in example this is the first position, next null not null, again go assign this address, next null not null, again assign this null, yes null. So this is stopping here, and I have assigned the address of this variable to ptr of next. Okay, now the view list, So view list is very simple. First we assign the pointer ptr to list address, initialized, start position, and check if list equals to null, so list is empty message. Okay, if list is not equals to null, so we comes here. Now this is the message cout, and while ptr is not equals to null means one by one we move to last position and print our data. So cout, then ptr of data, ptr equal to ptr of next, again check not equals to null, then print ptr of data, again check not equals to null, then print ptr of data. If ptr null, then stop the loop. Okay, so this is the list view list function. Here is the end class of my list. Now this is start the main. Okay, so I have created int data type my and my list variable my list. Okay, class my list variable my list system cls. So call I have here my list dot add node 3, my list dot add node 4, my list dot add node 9, and my list dot list view. Okay, so all first three times this function is called, and final list view. So output is like this initialized address this, and the all nodes are added backside. Okay, so this is the program of list linked list. Now dynamic allocation memory allocation chart for linked list. Okay, suppose if I assume all address like this stored randomly or dynamically created for data. Okay, so maybe, so this is the created the structure of this, because dynamic memory allocation, so we find the memory according to availability or unused position. So randomly we can use this memory to allocate the data. So all data is not the same or continuous location, this is random location, zigzag motion. Okay, so this is our program, and this is our output of variables. So all these variables like this. Okay, now we check the demo of our program. So this is the program according to our slide. So structure I have created here, two pointers I have created. This is the constructor here, and this is void add node function to insert a data, and this is the view list function to print the list. Okay, now this is the int main function, and this is our number, long number, which is show in our slide. Okay, now I have called add node function in this time. Okay, I can use like loop also if we add to it, but this time I am writing simple statement for this. Now all this number I have added, and this the last function view list is show the list. Okay, so now compile this project compile successfully, and run this project. So all list I have created for this variable. Okay, so this is the example of demo of linked list. Tell summary. Finally, we learned about structure or user-defined data type in C or C++. Also learned about the data type, what is primary and secondary data type, how to create structure, how to read and write in structure, accessing structure element by using dot or arrow sign. Okay, then check memory issue of array with large size of array. Okay, then learn what is self-referential structure and how to create. Then learn importance of self-referential structure and memory presentation, chart of dynamic memory allocation, and demo of linked list. Hope the tutorial will help to understand structure in C++. Thanks to watch Add or Tell Education.